Welcome, my friends. Consider this graph. Each week, a salesman named Fernando earns a fixed wage plus a commission for each sale he makes. Let's answer some questions. Firstly, what is Fernando's fixed wage? Well, the vertical axis represents 0 sales being made, at which point Fernando will earn a flat $500. So Fernando's fixed wage must be equal to $500. Secondly, how does Fernando's wage change for each additional sale he makes? This is a fancy way of asking for what the slope is. The slope is just the rate of change, which is what this question is asking for. Let's look at 2 identifiable points on the line to find the slope. I can identify 0, 500 and 3, 800. The slope is m is equal to y2 minus y1 divided by x2 minus x1, which is 800 minus 500 divided by 3 minus 0, or 300 divided by 3, which is just 100. That means for every additional sale Fernando makes, his wages must increase by $100 due to the commission. Let's look at another slightly different example. Here we have the weight in pounds and the miles per gallon of a car. This is not a perfect relationship, so we have the line of best fit created through linear regression. The equation of the line is y hat is equal to negative 0.4158x plus 37.19. We use y hat and not just y, as the line is a prediction for y and won't find y exactly. Let's answer a few questions. For a 100-pound increase in the weight of a car, how much is the miles per gallon predicted to change? This is a fancy way of asking for the slope. For a 1-unit change in x, or a 100-pound increase in the weight of the car, we are asked how much y, the miles per gallon, is predicted to change. We know the slope is the coefficient on x in an equation in the form y is equal to mx plus b, so the slope here must be negative 0.4158. For a 100-pound increase in a vehicle, the car is predicted to get 0.4158 less miles per gallon. Let's find the predicted miles per gallon of a car that weighs 4,500 pounds. Since the x values are already in hundreds, we have to divide 4,500 by 100 to find the value to plug into the equation. 4,500 divided by 100 is 45, so we must plug in 45. Y hat is equal to negative 0.4158 times 45 plus 37.19. If you plug that into your calculator, you should get 18.479. We predict that a vehicle that weighs 4,500 pounds will have an average miles per gallon of 18.479. Let's try one more example. Isaac has run 400 miles so far this year. He is currently running 45 miles per week. Let m represent the number of miles Isaac has run this year, and w represent the number of weeks from today. Let's find an equation to model the number of miles m that Isaac has ran this year, w weeks from today, assuming he keeps up his current weekly miles. M must be equal to the 400 miles that Isaac has already ran, but then he is running an additional 45 miles each week. That means each week we must add an additional 45 miles to his total. So if we were 3 weeks out, we would need to add 45 3 times, or if we were 10 weeks out, we would have to add 45 10 times, or in general, we have to add 45 w times, where w is the number of weeks from today. So our equation is m is equal to 400 plus 45 times w. Let's use the equation to find out how many miles Isaac will have run in 10 weeks. We can plug in 10 for m to get m is equal to 400 plus 45 times 10, which simplifies to m is equal to 400 plus 450, which is equal to 850. Isaac will have run 850 miles 10 weeks from today. Alright, my friends, that wraps up our video covering real-world applications of linear equations.